Hello friends, in this video we will solve some exam question on Z transformation topic. So the very first question we have here is poles and zeros are given. Now we have to find the pole zero plot, transfer function, difference equation and check whether the system is stable or not. So let's shoot the first topic, that is poles and zeros. In x-axis we have the real part, in y-axis we have the imaginary part. Now we have to plot the pole zero. So this is the unit circle. First zero is at -1. So this is the unit circle. So Z is -1 first zero. Second zero is at 1. So this is 1. So Z is equal to 1. Now we have to plot the poles. Pole is at 0.5 and pole is at 0.1 plus J times 0.2. So somewhere here. So this is 0.1 plus J times 0.2. Similarly 0.1 minus J times 0.2. So this is 0.1 minus J times 0.2. So these are the conjugate poles, these are the zeros and this is 0.5 pole. So first step is done, poles and zeros. Now we have to find the transfer function. Transfer function is very simple. This means we have to find h of z. H of z says I am is equal to 0 by pole. So he says I am 0 by pole, so let's write that. First we have to write 0 in the numerator. So you can see z minus first 0. So first 0 is -1. So z of minus 1 will become z plus 1. Similarly second 0 is z minus second 0. Second 0 is 1. So 1. So let's take a recap once again. We have to write z minus 0. So z minus the first 0 is -1. So z minus of -1, z plus 1. Next term is z is equal to 1. So z minus 0 is z minus 1. Now let's talk about the denominator. The same thing, z minus the poles. So first pole is z minus 0.5. Then we have this. So z minus 0.1 minus j times 0.2. Similarly z minus 0.1 plus j times 0.2. Okay. So we are done with the second step. Now we have to find the difference equation. To find the difference equation, we have to multiply this and we have to simplify this. So after simplification, after multiplication of all those terms, the simplified value is this is the simplification from that z. Now we have to write this in the form of z inverse of something. So we have to convert this into z inverse of something. So let's check what is the highest power of z. So highest power of z is z to power 3. So multiply everything with z to the power -3. Alright. So z to the power -1, z to the power -3 upon 1 minus 0.7 z to the power -1 plus 0.15 z to the power -2 minus 0.025 into z to the power -3. So you can see that I have multiplied in the numerator with z to the power -3 as well as I have multiplied z to the power -3 in denominator. After getting multiplication we get this term. Now why this is important? Because we are finding the difference equation. So h of z can be represented as y of z by x of z. Okay. Now cross multiply this with this. So what I have now is y of z minus 0.7 z raised to -1 y of z and so on. So now I have this after cross multiplication. Now we have to use the inverse z transformation. So inverse z transform. After using inverse z transform, y of z can be written as y of n. So this is 0.7 y of n minus 1. This -1 is because of the z to the power -1 power. So what will be the next? 0.15 constant will remain as it is. Now y n minus 2. Minus 2 because z to the power -2. Similarly for the rest, y of n minus 3, x of n minus 1, x of n minus 3. So this is the difference equation. So what I have done is first find h of z in simplified form. After finding h of z in simplified form, go for h of z which has z to the power -n term. So now h of z has z to the power -n terms. You can see z to the power minus 1, z to the power minus 3, so z to the power minus n terms. After that, split h of z into y of z by x of z and cross multiply y of z by x of z and cross multiply. After cross multiplication, use 𝐼𝑍𝑇 inverse z transform so that you can land up at difference equation. So the last topic is whether the system is stable or not. To check that, first we have to draw the unit circle and we have to place the poles wherever the poles were. So at 0.5 the first pole was there, second pole was at 0.1 plus j times 0.2. Similarly here 0.1 minus j times 0.2. Now you can note that all these poles are inside the unit circle. Whenever the poles are inside the unit circle, system is stable. So answer is yes, system is stable. So our second question is y of n is equal to y of n minus 1 plus x of n minus 1. We have to find transfer function, we have to find impulse response, and we have to find what is the response of step. So basically step response. So let's see how we can do that. First step, to find transfer function, take the z transform. So y of z is equal to y of z into z to the power minus 1. Now z to the power minus 1, because whatever is the value here, just raised to the power of z. So x of z again x of z into z to the power minus 1. Now rearrange it in the form y of z by x of z. Take the common values and place them right. So you will get the answer as z plus 1 upon z minus 1. So this is the transfer function. So we are done with the step 1. Now we have to take the impulse response. So h of z is equal to this value. So z plus 1 upon z minus 1. Because h of z is equal to y of z by x of z. Now take the inverse again. So h of n is the impulse response. So from transfer function we get impulse response by taking the inverse z transform. Okay, so this is, now you have to note that you cannot get direct value from here. We have to split that. So z by z minus 1, sorry, here we will write answer. Let's say we will split here z by z minus 1 plus 1 by z minus 1. Now we have to take the respective z transform of them, because this is possible. So the z transform of this is u of n, whereas the z transform of this is u of n minus 1. Why? We have to multiply divide by z. Now the third point is we have to find the step response. Step response means x of n is equal to u of n. This means that x of z is equal to z by z minus 1. So we have to replace x of z. So y of z is z plus 1 upon z minus 1 into z by z minus 1. If we simplify this, then we get z into z plus 1 upon z minus 1 the whole square. So this is the term we get. Now we have to find the inverse of this. Again, if we want to find inverse of this cannot be found directly. So we have to use the partial fraction. Note, wherever you have to find inverse of this, you have this some term, you have to split this term into the form some term plus some term. This will have denominator 1, this will have denominator 2, and so on. So basically either you can get directly or you have to use the partial fraction to convert the whole term into the splitted term. So here we will need the partial fraction, because in the previous case it was easily separatable, but here we have to use the partial fraction. So you can see that before you have to use partial fraction, we have to follow some condition. Now you can see that z into z plus 1 upon z minus 1 the whole square. The powers are equal of numerator and denominator. Let's take this power and throw it in the LHS. So now the power of numerator is less than the power of denominator. So we can write as a by z minus 1 plus b by z minus 1 the whole square. This is the rule of partial fraction when we have the same denominator power. That is, we have z minus 1 into z minus 1, that is z minus 1 the whole square. When we have this, we have to write the partial fraction in this form. After solving that, we will get the value of a and b, and they are 1 by, that is z minus 1 plus 2 by z minus 1. So the answer we get is, for a we get 1, for b we get 2. So I hope you know how to solve this partial fraction to get a and b. So rearranging the term y of z is equal to z by z minus 1. This z has multiplied in the right hand side, plus 2 times z by z minus 1. Now you can take happily the inverse of this. So y of n is equal to u of n plus 2 times n times u of n. sorry, this is z minus 1 the whole square. So because of this square we have the n term.
तो फ्रेंड्स, अगर आपको मेरी वीडियो पसंद आ रही हो देन डू लाइक दिस वीडियो, शेयर विथ योर फ्रेंड्स एंड सब्सक्राइब टू माय यूट्यूब चैनल। तो मिलते हैं अगली वीडियो में। टिल देन टेक केयर, दिस इज श्रेनिक जैन, पीस आउट।